And we also will be looking at how do we pick anti-log value while computation of your futures price. That's the core idea behind today's class. First part of the class. Second part, we will be moving into what we have been doing in our previous classes. So let's start with, I'm just, yes, here is a question with, no, in front of you. And the question is like this. The spot price of ABC Limited is given as 1,000 per share, and cost of financing, that is your R, is 15% per annum with continuous compounding. So it's been compounded on a regular basis. What should be the price of futures contract on this for a contract having a strike date of 30 days away from the current date? So you have a contract which will expire in 30 days. Now what you have to remember is one term called continuous compounding. If it was not the case, if you go with the simple compounding, it would have been easy for you to go with. You could have easily done using F is equal to spot into 1 plus R raised to T. But generally, when we are talking about financial derivatives in a market where continuous transactions trading are happening, we expect to have continuous compounding. That's why we don't go with using the formula for simple interest computation. So that is why I'm just putting the whole thing into, as we say, into a numerical formula. Okay, this is the whole thing, right? So as per our question, the spot rate is 1,000. Time, we know that 30 days, and we assume that there are 365 days, not a leap year. Okay, so 30 by 365. Time, rate 15%, so we take that as 1.15. 1.15, it's just converted into decimal. Now we know the formula. If we go with the concept of continuous compounding, that is spot is 1,000. Spot into constant, mathematical constant, which is applicable in such cases. It's actually the base value. Here we took E. It could be like in different calculations. Sometimes our base can be log base can be 10, or it varies. But here for this computation, the base is E as a constant. Now we know that it is E raised to R into T, right? So R, we know that 0.15. T also we have put the value as 30 by 365. Now, if it was a case like 1,000 into 10 raised to 2, or 1,000 into 5 raised to 2, or 5 or 6 or 7, we would have easily computed. But what we have to understand here is, in this case, it is not that. There is a case of decimal which needs to be solved. And solving that manually is not something so easy. We will commit error because there are a lot of decimal values which may not be displayed on our ordinary calculator. That's why we are permitted to use the log table. Now the concept here is, see, if I know this, okay, if I know this and I know the answer what I get, okay, that is, if I know the value, this value, okay, I know this value. This is if this is supposed to be X, and the answer which I get by solving Y, by solving this is Y, then I don't know this decimal part, this part here. That is what I would be looking into my logarithm table. Okay, I know this. I know the answer what I get after solving this, but I don't know this part which is enabled to me get an answer of Y. In that case, we will be looking for this in logarithm table. Okay, but now here in this case, we know this part, but we don't know the answer. In such a case, we will be looking into anti-logarithm part. Okay, that is, we know this part, we know the base, we know this, okay, but we do not have the value what we are getting when we really calculate this. In that case, we will be going into the so-called what we call as anti-logarithm. Okay, that is the concept where I will be looking into anti-log. So in this particular case, the cases we have to follow with looking up the anti-log table. So when we are looking into the anti-log table, how it happens here is, I'm just telling you how to go with, okay? Just making you revamp what you have learned in your previous years. So when you are looking into the anti-log part, this is the answer which I get by computing this decimal, that is 0.15 into 30 by 365. I have just rounded up this to four decimals because for me to look up anti-logarithm table, I want this in this format, 4 decimals. Why, I will tell you, okay? But this is how I have rounded and made this computation as a decimal. This is nothing but 0.15 into 30 by 365, right? Now you remember this value, 0.0123. 0.0123. I actually need to get a value for this 2.718282 raised to this. So I know that if I could compute it, that's what scientific calculator do. That's what computers do. They help me to compute this. Once I get a value for this, I just have to multiply that with 1000. But when I'm going with a simple calculator, or maybe if I'm going with the manual computation, that is difficult for me. So what I do, I go with anti-logarithm. Now, making you familiarize so that you don't forget it anymore. So here, in this case, this was the situation we were facing. We want to find a value for this. So we are going to split this. The first part of this, that is 0. The decimal, the first part of the decimal is called, in this case it is 0. It can be 1, it can be 2. I'll tell you the relevance of that. So here it is 0.0123. This part is what we call as characteristic. Okay, and this part is called as mantissa. This is what the actual computation, and this part is only for us to decide upon the decimal point. How many decimals we have to take. That's it. Which I will tell you. I'll be telling you. So this is called as characteristic, and this is called as mantissa. Okay. Now, what I will be looking at in the anti-logarithm table is this part, 0, 1, 2, 3. This part, I just keep it like that. I'll tell you what is the use of that. I'll be looking into the anti-logarithm table for this part, 0, 1, 2, 3. But what you have to remember is 0, 1, 2, 3. Okay. Now I'm going to show you how do I go with it. So this is one part, first part of the anti-logarithm table. It is just continuing. You have till 100. It's just continuing. I just took the first part of anti-logarithm table, and in that, the first part of our decimal is 0.02. Okay, so we are looking for that value here, 0.02. I mean 0.01. Okay, 0.01 and then 2. So what we have to do, we are picking from 0.01, we will be taking 2. I hope you're getting me. 0.01 and we are taking 2 here. Why? Because our decimal was 0.012. Okay, so that's why we are going with 0.01. We take 0.01. In that, we are going to take the value of 2. That is 1028. That's what I have written here as 1028. Right? I've written 1028. Now I have a 3 here. A 3 here. Right. So what I will be doing, I'm searching for in the same column 0.01 that I will be reaching to the end where I will find a value for 3. That is here in this case, the value for 3 is 1, right? Here in this column, I'm going with 1. So what I do? 0.028, the value which I got initially, plus 1, I'm going to get 1029. Okay, so this is actually my value. Now the role of characteristics come. Suppose if it is 0 here. So anti-log is nothing but the characteristic tell me how many decimals I have to put. If it is like this, characteristics plus 1. So here I am just going with, since it is 0 here, I'll go with 1 decimal. Characteristic plus 1. So here I'm just going with 1.029. But if it was, say, if it was 1, then I will go with 10, that is 10.29. I will take 2 decimals. If it was 3, I will take 3 decimals. Right? Like, no, if it is 2 here, then plus 1, 3 decimals. 4 here, plus 1, 5 decimals. Only till that normally it happens. After that, we have a different calculation. But normally we will be having such values. Otherwise, it should be a huge value. So this is how it happens. So we have characteristics and mantissa. So we got the value you took from the anti-logarithm table. Then we applied that characteristic plus 1. So here it is 0. So plus 1 means 1. So we put 1 decimal. If it was 1 here, plus 1 means 2 decimal. But in this case, it's only 1. So this is my value. My value for this part. This is what you are finding it difficult. It's not that you didn't understand the concept. So this part is actually the value which you have to take it from the anti-log table. So I am going to get 1.029. Now what I'm going to do, things are very easy for me. Future price is equal to spot into this. So my spot is 1000. 1000 into this. That's what I get here. Yeah, this is all about computation using an anti-logarithm table. Why? Because anti-logarithm is a situation, is a table which we will be referring to. Anti-log is a table which we will be referring to when we want a value for this. It's not that it is not possible to compute using a calculator. You can easily. In fact, in a scientific calculator, you have straight away anti-log. You can give the value, you can give the base, you can give the part, and I mean E is your base, right? So you give your base and this part, you will get the answer. But that is not possible for your university exam. You have to do it using the log table, right? So that is why for us to find out this, we are going to use the anti-logarithm. It's all about computation. We just knew the formula. The same thing applies when you have, say, as you say, carrying cost. Okay, carrying cost. If you go with the same formula will be, suppose if I am talking about 2 rupees carrying cost for 1 kg of wheat. So what I have to do is initially 2 into e raised to r into t. I have to compute it. Then it will be like s plus u whole raised to the same thing what you have been doing. Right? Instead of s, you will have s plus u, where u represents the carrying cost. Then the formula becomes normal after that. But initially, you have to go with the computation of the carrying cost using the formula. Say if it is 2 kg, 2 into this e raised to. Because we want to find out what is the carrying actual value of the carrying cost. So again, the value of E will be computed from the not value of E. The solution to this part will be done using the anti-logarithm table. That's it. So you can take the Antilog table for your university examination. Only thing is that there should not be any marking, there should not be any writing, it should be brand new one. So that's what it's all about. Right.